Hey guys, Mr. Backward here. In this video, we're going to look at quadratic inequalities. So as we're looking at a quadratic inequality, we're going to be looking at something of the form ax squared plus bx plus c is greater than 0, or it could be ax squared plus bx plus c is less than 0, and where we have that greater than and that less than, that could also be greater than or equal to, or less than or equal to. That would work as well. Now, what's different about solving a quadratic inequality versus a quadratic equation, when we're looking at a quadratic equation, we get specific numbers as our answers, but as we're looking at inequalities, instead of just getting certain numbers, we're going to get a range of values as our answers. So in this first example, we're going to look at the inequality x squared minus x minus 12 is greater than 0. And we're going to treat it just like we would a quadratic equation, and we're going to try to get that left-hand side factored out. So to get that x squared, we're going to need x and x. We need numbers that are going to multiply to negative 12, but add up to negative 1 in the middle. So that's going to be a positive 3 and a negative 4. Now, if we solve each one of these, if we set them equal to 0, x plus 3 equals 0, we would have to subtract that 3 over, so we would get an x value of negative 3. And for this one, if we take that x minus 4 and set it equal to 0, we're going to get x equals 4. Now, if this were a quadratic equation, we would be done. Those would be our answers. But it's not. We're dealing with an inequality here, so here's where things get a little bit different. What we're going to do with those is we're going to plot those values out on a number line. So 0's right here. I'm going to throw negative 3 over there, and I'm going to throw 4 on the right-hand side there. So we call these values critical numbers, and we want to use those critical numbers to help us out. These numbers are going to split our number line into some different intervals, and we want to test our intervals to see what kind of values we're dealing with. So the first interval that we've got on the left-hand side is all of the things that are smaller than negative 3. So what we want to do there is we want to pick out a test value from that interval, so something smaller than negative 3. So we could use maybe negative 5. Then what we're going to do with that negative 5 is we're going to take that and plug that back into our inequality on the left-hand side to see what kind of answer we get when we plug that in. So we would take negative 5, square it, minus negative 5, and then minus 12. Now, negative 5 squared is 25. This double negative turns into a plus 5, and then minus 12. So 25 plus 5 is 30, minus 12 is 18. So because we got a positive number, that means that this interval on the left-hand side is a positive interval. Now, our next interval that we're going to look at is between our two critical numbers, so between negative 3 and 4. Now, 0 falls in between there, so 0 is a nice test value to use if it's available to you. So we're going to plug in that 0, so we get 0 squared minus 0 minus 12. 0 squared is 0, minus 0, we've still got 0, and then minus 12 is negative 12. So when we plugged in something between negative 3 and 4, we got a negative answer. And then our last interval is going to be from 4 on up. So maybe we choose to use 5 in there. So if I plug in 5, we get 5 squared minus 5 minus 12. Now 5 squared is 25 minus 5 minus 12. So 25 minus 5 is 20. Minus 12 is 8. So we got a positive answer there, which means that this interval on the right-hand side is a positive interval. Now, if we go back to our inequality said we wanted things that were greater than 0, and positive numbers are greater than 0. So we want to focus on these positive intervals. So that first interval on the left-hand side actually starts at negative infinity, and then that interval stops when we hit negative 3. But then we've got this other interval over here, which starts at 4 and runs out to positive infinity. Now, I used parentheses around these end values because my inequality does not have the equals to line underneath it. So that means that these end values are not included. So then these two intervals combined, I'm going to put a union symbol between them. The union of these two intervals is our solution set. We're going to look at another quadratic inequality here. So we've got 2x squared plus x is less than or equal to 6. Now this one's a little bit different because this one doesn't have 0 on the right hand side, but it should be pretty easy for us to get 0 over there by just subtracting that 6 over to the left. So then we would get 2x squared plus x minus 6 is less than or equal to 0. Now because of that 2 in front of our x squared, we're going to have to be a little bit careful when we do our factoring. So to get 2x squared, we're going to need 2x and x. Now with that 2x, this is going to be guess and check. We need numbers that are going to multiply to negative 6. So it's either 1 and negative 6, or it could be negative 1 and positive 6, or 2 and negative 3, or negative 2 and positive 3. And we need to come up with the combination that's going to give us that positive 1 in the middle when we do our check. And it actually ends up being 2x minus 3 and x plus 2. And I'll show you the check real quick. In the middle, if we multiply those together, we would get negative 3x. And on the outside, if we multiply those together, that would give us 4x. And if we combine those, we do get that positive x in the middle. So then what we're going to do with these is we're going to take these two factors and we're going to set them equal to 0. So 2x minus 3 equals 0. I'm going to add that 3 over, so we get 2x equals 3, but then I'm going to divide by the 2, so we get x equals 3 halves. And then over here, I'm going to take the x plus 2 and set that equal to 0, and subtract that 2 over, so we get x equals negative 2. Now these are our critical numbers, so I'm going to plot those out on my number line. So we've got negative 2, so I'm going to put that on the left-hand side over here. 0 is going to be in the middle. Then we've got 3 halves on the right-hand side. Now just like we saw on our last example, we want to use these critical numbers to help us out, because these critical numbers break our number line up into our different intervals. So the first thing I want to do is pick a test value, and I'm going to start on the left-hand side, so something smaller than negative 2. So maybe we choose to use negative 3. Now I'm going to plug this into my rearranged form once I get 0 on that right-hand side. So if I plug in that negative 3, then we're going to get 2 times negative 3 squared plus negative 3 minus 6. Now negative 3 squared is 9. 9 times 2 is 18. Minus 3 minus 6. So 18 minus 3 is 15. Minus 6 is 9. So we got a positive answer, which means this interval on the left-hand side is a positive interval. Then I want to plug in something between my critical numbers, so between negative 2 and 3 halves, and 0 is in between there, so 0 is going to be a nice number to plug in. So we're going to get 2 times 0 squared plus 0 minus 6. 0 squared is 0, 2 times 0 is still 0, plus 0 is still 0, and then minus 6 is negative 6. So this interval in the middle is a negative interval. And then on the right-hand side, we want to plug in something bigger than 3 halves. Now 3 halves is 1.5, so maybe we choose to use 2. So we take 2 times 2 squared plus 2 minus 6. 2 squared is 4, and 2 times 4 is 8, plus 2 minus 6. So 8 plus 2 is 10, minus 6 is 4. We got a positive answer, which means that this is a positive interval. Now looking at our rearranged inequality, we want things that are less than or equal to 0. Less than 0 means negative, and we've only got one negative interval, and that's the interval between negative 2 and 3 halves. So from negative 2 to 3 halves, this quadratic is negative. Now we have to be a little bit careful here because our inequality does have the equals to line underneath it. So we do want to include these end values on our interval. So I'm going to put square brackets around them. So that's our solution set from negative 2 to 3 halves, including those end values. That's going to be it for this video. Thanks for watching.